Hello everyone, I'm just going to make a quick video about how black holes are formed, and you may think, well, I know how black holes are formed, why am I watching this video? What I'm going to describe it to you is how it's formed on the fabric of the universe. And you may be thinking, well, what the hell is the fabric of the universe? What's this? I've never heard of this. You know, some people know about it, some don't. If you don't, the universe is like a massive piece of paper or a massive net. However how you want to picture it is. I picture it as a giant net. As you can see in this picture, it looks like a giant net. That's how I picture the universe. Okay? In the next clip here, this is what the sun and the earth looks like on this fabric. As you can see, the sun's doing it. It's made a bit of an impact on this fabric, as you can clearly see. In some sense, it's made it look like a bit of a roulette wheel, if you want to call it that. And as you can see, the Earth, yeah, it's made a bit of a dent there. No, it's made a bit of an impact, but not much, not as much as the sun has. Okay. And what this picture is saying to you, this is showing you how it orbits around the sun on this fabric. And yes, this is how it orbits. But what it's like a roulette table, okay? And the Earth is going around this roulette table. It's stuck in this constant motion of going around and round and round. This is due to this effect. So it's just going around and round. People call it gravity, or whatever you want to call it. But this is what it's like, okay? Right, the next clip here. This is the life cycle of stars, okay? Don't know why it says of a star. Well, it makes sense, I suppose, actually thinking about it. But whatever, okay, forget that. Okay? Everything starts in a stellar nebula. Everyone knows that. That's where stars are born, how they're made, etc. Okay? And what we're going to do, we're just going to follow the average star's life cycle, okay, for now. An average star, it's like ours, normal, it's fine. Basically like where our star is at now. But eventually it will use up all its fuel, all the hydrogen and all that will eventually be spent, resulting in it going into a red giant. And it gets bigger because it's the core is trying to not get crushed. It's trying to force it away, so it's getting bigger and bigger and bigger. It's basically feeding on itself. It's became like a cannibal. It's cannibalizing on itself, so to say. Then eventually when it does collapse, it goes into what you call a planetary nebula. Basically when it explodes, it goes boom, so to say. Then it goes into a white dwarf. This is basically it's basically the remnant of the star. It's just its core left over, just glowing there, but extremely dense still. Extremely dense. Probably much denser than it was as a red giant. So you kind of get, excuse me, kind of getting the picture there. Right, now we're going to follow the massive star route. Massive star, well, it's much bigger than the average star. Then once again, it's going to burn up all its fuel. It's going to go into now a red supergiant, much bigger version of the red giant. And once again, once it uses up all its, when it can't take its pressure anymore, it will go boom into a supernova. But this is the point where, depending how big that star was, it all depends on how big it is. Sometimes it will go into what you call a neutron star, which is basically the leftover, but it is extremely dense on the fabric. But then what happens the other way? It can go into a black hole, and this is where the laws of physics breaks down. In a sense, in physics, this shouldn't exist. It's an impossibility. Yet there it is. It's there. We know they're there, and that's a black hole. Right, the next clip I'm going to show you here. This is what a black hole looks like on the fabric of the universe. As you can see, it's made a massive impact. It's literally collapsed. It's a giant hole. So you get the idea. It's pretty screwed up. It's broken everything down. But what I'm going to show you is on a more of a detailed scale to show you exactly how far this thing has dipped into the fabric of the universe. So here in this clip, now you can see just how far it's gone all the way down. It's gone a long way down. It's come to a point where at the bottom it's ripped the fabric of the universe. It has ripped it to shreds. It's now a hole at the bottom. This thing shouldn't exist, but this is where the singularity exists. It's now down in there. Now some people will think, well, can't we just jump into one of these and check it out? No. You can't just simply jump into a black hole. There's a lot more that goes on in there. Where the X and the Y is, this is the event horizon. You think, well, wouldn't the event horizon be up the top there? No, because this is the dip. This is before it goes in. The event horizon is much further down into the hole. But this is the point of no return. You can't get back from this. Once you go past this event horizon, you might as well stick your head between your legs and kiss your ass goodbye, because you're not getting out. Light can't escape from it. Sound can't escape from it. Radio waves can't escape from it. But there has been known to be two things that can escape from it. One is radiation, and the second is a magnetic field. So there's two things that can escape from it. But everything else, light, everything else, it's not getting out, basically. So I know this is a short video to explain it, but I thought I'd just break it down, make it easy to show you on the fabric of the universe and just what it looks like, basically. So I hope you enjoyed this video. Like, comment, and subscribe. And if you've got any suggestions or anything, drop them in the comments below, and I'll probably make a video on it or something. Just drop them down and I'll take a look. Alright guys, thank you for watching, and take care.